All right, let's jump right in. Today, we're going to talk about the science of mixing things together. What really happens when something like sugar seems to just vanish into a liquid? We're going to break it all down. This is going to be fun.
So, have you ever been making tea or maybe some lemonade and you stir in the sugar and you watch it just completely disappear? Poof, gone. Where'd it go? It's not magic, I promise you. It's science. And by the end of this, you'll know exactly what's going on.
Okay, the easiest way to think about making a solution is to imagine you're following a really simple recipe. And like any recipe, you need ingredients. For a solution, there are just two main ones we need to know. Let's meet them.
So, ingredient number 1 is called the solute. That's a key word. The solute is the thing that gets dissolved. It's almost always the smaller part of your mixture. So, if you're making salty water, the salt is your solute. Making hot chocolate, the chocolate powder, yep, that's the solute.
And our second ingredient is the solvent. The solvent is the stuff that does the dissolving. It's the larger part of the mix. Now, water is like the most famous solvent on the planet. It can dissolve so many things. But milk can be a solvent too when you add chocolate powder. And the hot tea itself, that's the solvent for your sugar.
So, here's the super simple formula to remember. You take a solute, you add it to a solvent, and what you get is a solution. It's that simple. Salt, our solute, plus water, our solvent, equals salt water, which is a solution. You've probably been making solutions your entire life without even thinking about it.
Okay, so let's talk about that disappearing act. What is actually happening when the solute vanishes? Well, the sciencey name for this magic trick is dissolving. And when you understand how it works, it's actually pretty amazing.
Let's zoom in and see what's happening at a microscopic level. First, you drop your solute, let's say a sugar cube, into the solvent, which is our water. Right away, that big sugar crystal starts breaking apart into tiny little pieces called molecules. They're way too small for our eyes to see. Then, the water molecules grab onto these sugar molecules and pull them away, spreading them all around until they're mixed in perfectly evenly. That's dissolving.
And this is maybe the most important thing to remember. The sugar didn't actually disappear. It just broke down into pieces so small and spread out so well that you can't see them anymore. But it's definitely still there. You can taste it, right? The solute is still there. It's just mixed in perfectly.
Okay, so this brings up a really good question. Is every single mixture a solution? And the answer is no, not at all. Let's take a look at the two main types of mixtures you can have. So on one side, you have a homogeneous solution. The word homo just means same. And that's the key. This mixture looks exactly the same everywhere you look. It's totally uniform because the solute has completely dissolved. Think about salt water. But on the other side, you have a heterogeneous mixture. Hetero means different. And with these, you can actually see the different parts. The classic example is oil and water. The oil doesn't dissolve, it just floats on top. The substances stay separate. It's a mixture for sure, but it's not a solution.
All right, let's talk about something we all understand. Making a drink taste really strong or kind of weak. Well, this idea has a scientific name too. It's called concentration.
Concentration sounds complicated, but it's not. It's just a way to measure how much solute, how much stuff, you've managed to dissolve in your solvent. Is your drink super sweet or just a little sweet? That's all about concentration.
Now, if a solution only has a little bit of solute in it, we call it a dilute solution or diluted. Think about really weak lemonade. It has just a tiny bit of sugar and lemon juice mixed into a whole lot of water. We'd say that has a low concentration. And the opposite of that is a concentrated solution. This is when you have a lot of solute packed into the solvent. Ocean water is a perfect example. It's super concentrated with salt, which is why it tastes so, well, salty. If you kept pouring sugar into your tea, you'd be making it more and more concentrated.
So why are we talking about all this? Is this just some cool science fact? Well, no. Because once you start looking for them, you realize that solutions are absolutely everywhere. They are a huge part of our world and our lives.
I mean, just think about your day so far. That coffee or juice you had for breakfast? That's a solution. The soup or sauce you might have for lunch? Total solutions. Even the cleaning products we use, the medicines that make us feel better, heck, even the chemical reactions happening inside our own bodies all rely on solutions to work.
So I want to leave you with a little challenge. Based on what we've just talked about, what's one solution that you've already used today that you never really thought about as a solution before? Once you start looking, you'll see the science of mixing is all around you. Thanks so much for tuning in.